Relations and functions. I'm Anil Kumar, and in this video we are going to discuss what is the difference between relation and function, which relations are functions and which relations are not functions. Well, let me start with the relation we are born with, that is child to mother, right? So I'm calling this relation as mother. I love to start with this relation. Now on this earth, every living being will have a mother, right? So every living being, let's say this is on one side, will have a mother, right? So every living being has a mother. Well, at times, two people or more can have the same mother, right? So a mother can have more than one child, right? So that is how it goes. So what we find is that on this earth, every living being will have a mother. So there is a rule by which the two things are connected. So this is one group which we are calling as set A. We call this as a set A. And then we have another group here which is set B. Now set A is set of, let us say, children, right? Let's say child, and set B is all the mothers. The association is that every element, so these individuals which I have marked here are called the elements, right? So these are the elements, so we say elements. These are technical terms which we should know. So every element in set A is associated with the elements in set B, right? Now, at times we also call them as input elements and the output. Well, few other terms, let me introduce them to you now. This set of elements is also called domain. Domain basically is all possible elements which could get into the input. And the other set is called the range. What these inputs are associated with. Now in this particular example, what we saw is that the relation is 1 to 1 or even many to 1. Even if there is one particular case which is many to 1, we will call this relation as many to 1. Okay, so I'll just call this relation as a many to 1 relation. Now it is a relation since each and every element in our set A is related with one or more elements in set B. Do you get the point? One or more. That means we could have one or more association and still it works, right? So mother has another child. So what we have, this child, well, this is a wrong line which I made. Well, let me correct it. Another child may be associated with the same mother, so mother has another child, right? Do you see that part? So what we find here is that there could be instances where many are related with one, so in that case we'll call this as many to one relation. Now the important thing here is, if I say that my mother is an excellent cook, you understand for whom I'm talking, right? My mother is unique. Now that is what we call as a function, right? So function is the one in which every element is associated with at least just one element on the other side. Okay, so many could be associated with one. Okay, so in that case we'll say it is a function. Well, let me flip the situation to understand it slightly better. Let's now say that we have another relation which we'll call child. So here we will have set of mothers and here we have a child. Now a mother can have one child, a mother can have two children, correct? So the arrows indicate the association. It is from this side, which is input, and the other side is the output. Correct. So a mother can have many children or just one, right? Like this. There is a relation between the two groups, mother to child. Now if a mother says that my child is always asking for money, then we are not sure which one. Because a mother can have more than one child, right? So we are not quite sure. So there is an ambiguity. In mathematics, we do not like to have those ambiguities. And so we have a different term. We say, well, that relation is not a function. So we'll say this is not a function. But on the other hand, my mother, you know exactly about whom I'm talking. So that is a function. So both are relations, but one is a function, the other one is not. This one is a function since every element in our set A is associated uniquely with just one element in the set B. However, in the other, where the relation is bound by the rule my child, mother to child relation, a mother could be associated with more than one child, and therefore it is not a function, it is still a relation. Okay, so that is how we distinguish between relations and functions. So what we saw here is, even if it is many to one relation, it could be a function since each element in our group is actually associated with just one element, right? Now in many to one it is possible that we may have one to one also, right? But if even one has many to one relation, it will be called many to one relation. Okay. Now let me talk about another relation, and that is the relation which we die for or we live for. Well, when we landed here as an immigrant in Canada, we were given a SIN number. So that is the SIN number which we have. So every individual here in this country will be associated with the SIN number. So let me call this a relation, right? So any immigrant who is a permanent resident here will have a unique SIN number. So in this case, it is not many to one or one to many, it is just one to one, right? So every individual here will have unique identifiable number, which we are calling as a SIN number. So this is like a relation in which one-to-one relation, right? So this relation one-to-one is also a function. This is one-to-one relation. One-to-one relation is also a function since each and every element in our group of input has a unique association, right? And what we see from all the three examples, that many to one relation could be or is a function, one to one relation is a function, but one to many is not a function. One to many is not a function. So that in short gives us an idea about what relations could be functions. Important thing to note here is that functions are relations. All relations are not functions. Well, the relations which are many to one or one to one, where each element in the input is associated uniquely with just one element in the output, will be a function, others won't be a function, right? So one to many will not be a function. As far as functions are concerned, I showed you with the help of a mapping diagram. We'll further explore functions and notice that how to distinguish between a relation and function if it is given in different forms. So one of them is graph. So on a graph, if I have a relation which is kind of like this, then as you can see, for a value of x, we are having two values of y. That is to say, if I draw a vertical line, it intersects at 2 points. So that relation is not a function. We say it fails vertical line test. So graphically, we can always see whether a relation is a function or not with the help of this vertical line test. Now, let me give you another example here. For example, we could have just set of points, right? So if we have a set of points like this, where 2 lie for the same value of x, 2 different y values, right? Others may have a unique x and y value. But this fails the vertical line test, and therefore this will not be a function. It is still a relation. Okay. So a function would be kind of a graph like this, right? Do you see this? Now here, if you draw a vertical line, it will cross only at one point. So this graph links you with a relation and a function. So this is a function which passes vertical line test. Now another way of looking into functions is when we are given them in ordered pairs. So in this set, if I write numbers like 1, 1, 2, 2, 2, 3. Now here we see 2 is linked with 2 and 2 is linked with 3. Therefore, it is not a function. So since 2 is repeated and 2 which forms a part in the input, these are all the domain elements, input elements, and the y elements in a coordinate pair corresponds to the output elements. Now we see that 2 is associated with 2 and 2 is also associated with 3, and therefore this one is not a function. Whereas if I write a relation which is kind of like this, 1, 1, 0, 2, 3, 4, then every element x input element is associated uniquely with just one output element, the y coordinate. So this one is a function. So when given in the ordered pair form, we are looking for matching x values. If you find one, then it is not a function. Okay, but if you don't find any repetition of the x coordinates, then it is a function. So that is how you can check. So I have told you how to see whether a given relation in the form of mapping diagram could be a function. So in a mapping diagram, you should see that it originates and doesn't go in a V shape. If it goes in a V shape, that means more than one, it is not a function. Now, when given as a graph, it should pass the vertical line test. When given as a set of ordered pairs, then the x values should not repeat. When we're talking about a statement saying a relation of my mother or my child, now a mother can have many children, so there is a possibility of ambiguity which child we are talking about, and therefore that is not a function. So what we discussed in this video is all those relations are functions where each and every element in the input is associated only with one element in the output. In a relation, you should remember that each and every element in the input can be associated with one or more, right? So that's the key word. So we say that in relation R, it is one with one or more, right? And in a function, it is one with just one, right? No more. So that is the key thing here, right? So we'll explore more examples here to understand which relations could be functions, which relations are not functions, and what the reason could be. I hope you'll find this interesting and helpful. Thank you and all the best.